interchangeably, so I just want to make sure that this doesn't throw you off. But sometimes instead of saying inverse tangent this way, we say arctan, or sometimes instead of saying arc cosine, we say inverse cosine, arc sine, and inverse sine. Those all mean exactly the same thing. So even your textbook, which we won't get to a textbook assignment until Friday, interchanges these. Question 1 might say arctan, and then the next question might say inverse tangent, but they mean the same thing. Okay, and to really understand, before we get into what you have to memorize, there's 6 things that you have to memorize new in this section, and then what kind of questions you're going to look at. Really, this whole first page is trying to build up and help you understand why we're doing what we're doing and why it has to be done. So this will help you, I don't know, maybe not get the answers to the next quiz, but your understanding of why it's all necessary. So the way we've currently been using the unit circle is you would have a question like the sine of 30 degrees. So 30, the input is an angle, and then the output, your answer, is a ratio. So you'd go to 30 degrees, you would have that point memorized, and if you want the sine value, you want the y value. That's how we've used the unit circle up until this point. But with inverse trig functions, inverse just means that you're swapping input with output. So now the input is going to be the ratio, and our output is going to be an angle. So we're giving you the opposite information and expecting the opposite information, but it's still the same old unit circle. So this question, 5-second description of it, it's deeper than this. We'll have to come back to question 3 when we're done with this page. But a 5-second description of this is saying what angle has a sine of square root of 3 over 2. So if we start going around the unit circle, this place has a sine of square root of 3 over 2. Inverse trig functions are only defined in radians, so we're only doing things in radians in this section. But this point has the same y value, so it has the same sine value, 2 pi over 3. And if you're willing to go a full rotation and start thinking about coterminal angles, you could do 2 pi plus pi over 3, which would be like 7 pi over 3. And then this one would be 8 pi over 3. And you could just keep going around the circle multiple times. There's infinitely many angles that have that sine ratio. But inverse trig functions like this only have one answer. So again, the rest of the page is trying to set you up to understand why there's only one answer and which one of these is the final answer that we need. Not all of these will be acceptable. Okay, so hopefully you guys did some inverse functions in algebra before, and chances are if you did, if you remember that, your teacher probably said switch x and y and then solve for your new y. But what you're really doing is swapping input with output. So in an algebra course, the input's usually x and the output's usually y. But for us, in trig functions, the input is going to be the ratio and the output is going to be an angle. Okay, and then the other big thing here to understand where these values are coming from is that in order for a function to have an inverse function, it has to be called something called one-to-one. So if you don't remember this term from Algebra 2, you probably want to make sure you're familiar with it, because I think they do use this terminology on ACT. To be one-to-one, it has to pass the vertical line test, which makes it a function, and it has to pass the horizontal line test, which makes its inverse a function. So one-to-one is important because it tells us a function's inverse is also a function. It's got to pass the vertical line test and horizontal line test. So that's important in math. We need it to, we want the, not just to have an inverse, but we want that inverse to be a function. We work with functions all the time. Lots of things we can do with the function that we can't do with just a relation. So the problem is, and I don't make you go over all 6 trig graphs here just for you to see where this comes from, but I do expect you to at least figure it out with this one sine graph. So I'm not going to do all 6, but more important that you see what's going on with the sine one. So we know what the sine graph looks like now. Is this guy, let's see, past the vertical line test? Any vertical line we draw hits the graph at most once, which is why he is a function. Is he passed the horizontal line test? No. So there's at least one horizontal line I can draw that hits the graph more than once. So he's a function, but he doesn't pass the horizontal line test, which means we can't call him one-to-one, which means his inverse is not a function. That's a problem for us. But it's a problem we can fix. So in mathematics, sometimes we say, what if I was to ignore this part of the graph and this part of the graph, or ignore that part of the function and that part of the function? And there's a mathematical term for that, and it is called restricting the domain. So it's just a fancy way of saying, hey, we're going to ignore the stuff that's not helping us. And we try to leave behind as much of the graph as we can, but we need to leave make sure that what we leave behind is one-to-one. So notice that piece that I'm choosing not to ignore not only passes the vertical line test, but also the horizontal line test. Well, if we take this guy is going from negative pi over 2 to positive pi over 2. And so this would be his domain, possible x values. But on a inverse function, when you're switching x and y, you're swapping input and output, this guy's range, or domain, becomes this guy's range. And then this guy's range, negative 1 to 1, becomes this guy's domain. When you swap input with output, you're also swapping in domain with range. Possible x values become possible y values. Possible y values become possible x values. So what you need to get out of this, before I tell you how this helps us with our answering question 3, is sine by default is not one-to-one, which is a problem because we want this inverse to be a function. So we choose to ignore part of the function called restricting the domain. This new restricted domain becomes the range of inverse sine, and his range becomes the domain of inverse sine. Now, why this is important is that for inverse sine, his range is negative pi over 2 to positive pi over 2. These are the only values that exist for inverse sine. So if we go back up to question 3, there's infinitely many answers, or infinitely many angles that have a sine of square root of 3 over 2, but only one of them is within that range. If the range was negative pi over 2 to positive pi over 2, which one of these should we keep? The first one, pi over 3. That is the one and only correct answer. There's only one correct answer here for each of these questions. So a couple things that I hope are jumping out at you pretty early. We do spend 3 full class periods on this one before we quiz, by the way. So that'll be all this week. I see you guys Tuesday, Thursday, and Friday. And so we'll be quizzing on this time next week. But it will feel like a lot of information here for about the next 30 minutes or so. But what I hope is jumping out at you is A, you got to know the unit circle. If you don't know where sine is this ratio, then you're stuck at step 1. B, you're going to have to memorize the range of the 6 inverse trig functions so that you know where to pick your answer from and where not to pick your answer from. And then C, you've got to make sure that you name it carefully. Sometimes you'll see that you might want to call an angle 5 pi over 3 because that's the right location, but it may not be within the range. So that can make the questions a little bit difficult, but one piece of that is we have to memorize these ranges. So the bottom of this page was actually supposed to print off on the top of the next page. I apologize, I just didn't notice until it was too late and they'd already been copying. So I'm going to copy these back down. And instead of inequality notation, we're going to do interval notation here for the 6. Okay, so what we just talked about is we discovered why the range of inverse sine is negative pi over 2 to positive pi over 2. And again, you will have to memorize that because your answers have to fall in between those values. Now, some people like to memorize the intervals, and I could just write out the 6 interval notations and they can memorize them that way. But most people do much better with this unit circle type visual. So when we work inverse sine questions, we're going to draw this on our paper. It's a visual, like the unit circle, that our answer needs to be between negative 2 pi and positive 2 pi. Well, luckily these two are almost the same thing. The difference with inverse cosecant is that he can exist in the middle, and inverse tangent can exist at the ends. So this one we would say negative pi over 2 to 0. Don't include 0, but then 0 to pi over 2. This one's negative pi over 2 to pi over 2. But he needs parentheses instead of brackets, because he can't include those ones. So every time we work any of those 3 types of questions, our answer has to fall within those values. It's the only acceptable answer. Then, luckily, there's some patterns here, so we're not just memorizing 6 completely random things. Inverse cosine, inverse secant, and inverse cotangent all look similar. This one is 0 to pi. Inverse cosine is 0 to pi. His reciprocal has a hole in the middle, just like this guy's reciprocal had a hole in the middle. So 0, don't include pi over 2, and pi over 2 to 0. And then just like this one, looks like this one, but he's undefined at the endpoints. This one's going to look like this one, but undefined at the endpoints. So when we work an inverse cotangent question, our final answer has to be something between 0 and pi. Can't be 0, it can't be pi, but something in between. The one other connection that I think is sometimes helpful, for those of you that remember which functions are co-functions of each other, one of those seemingly random identities we ask you to memorize, but sine and cosine were co-functions, secant and cosecant were co-functions, and tangent and cotangent were co-functions. And if you notice, each of these are just a rotation of each other. If you took this one and rotated it left, or took this one and rotated it right, you'd get the other one. If you rotated this one left or rotated this one right, you'd get the other one. If you rotated this left or rotated this right, you would get the other one. So knowing which functions are co-functions also makes it where you're having to memorize less. But at the end of the day, we need to know these 6 ranges. And again, for most students, drawing these little unit circle pictures with each question is the most efficient way to memorize that, because you got more of a visual. Okay, so the 2 type of questions that are going to make up about 80–90% of what we do in this section, the questions that are going to take the most amount of practice and what we're going to spend the rest of class on. Either A, we get a inverse trig question and the ratio sounds like something on the unit circle, so we're going to work it like a unit circle question. Or B, we get a ratio that does not sound like something we memorize on the unit circle, and it's going to be a question we have to sketch the triangle. 80 to 90% of the questions we're going to do fall into one of these two categories. Now they do take a lot of practice, so one example on your notes is not going to be nearly enough, but I do want you to have a good detailed example where you might elaborate and add some words to it. But for these question types, you need really 3 steps for all of them. Step 1, you need to go around the unit circle, make yourself a visual. You've got to label everywhere where you think sine is -1/2. And if you know the unit circle, that should take you about 2 seconds or less. And if you don't consistently get that correct, you have to force yourself to practice the unit circle more. Make a blank unit circle on a random piece of paper, check it with your notes, check it with Google. If something's wrong, then keep practicing. You have to know these values. So that's always going to be step 1 on those type of questions. Step 2 is you got to think about the range of inverse sine. So over the course of the next 3 days, as you memorize this, the range of inverse sine is -π/2 to +π/2. This gives us a visual to see that our answer is supposed to come from this spot and not supposed to come from this spot. Also, if we draw it in every time, then we're slowly memorizing the range of inverse sine. Today you'll just have to look at your notes a lot, but over time you should try to look at your notes less. And then finally, if this spot is my answer, I'm going to be tempted to call it 11π/6 because that's what I normally call that spot. But 11π/6 is not between these two values. So you got to think of a way to name that angle the same location that is between these. And so what could that be? -π/6. That's the only correct answer. So have to know the unit circle to know where sine's -1/2. You eventually have to memorize the range of inverse sine to know which spot's your answer and which spot's not your answer. And then finally, you have to make sure that you're not just naming the correct spot, but naming the correct spot within that range. So that'll be about 50% of what we do in this section. Okay, when we look at this one, because the questions will be scrambled, it won't be obvious whether you need to go to the unit circle or not. But if you see a ratio that does not sound like something we memorize on the unit circle, whether it's numbers or x's, then you're going to have to sketch a triangle for this question. Now notice on the outside it says cosine, so some of these questions kind of have a second layer to them, but we just put that on the outside and we'll worry about that at the very, very end. And for this guy, I can't give you a number, a numerical angle that has a sine of 2x, partly because it's not possible with x. So what I can do is I can sketch a triangle that shows what that looks like. Now, this is really these are longer questions, so in that sense that they're harder, but it's really the next 10 seconds of what I'm about to say is the only part that's new. If you think about the range of inverse sine being -π/2 to +π/2, you know that he only cares about quadrants 1 and 4. So when you sketch your triangle, it has to be quadrant 1 or quadrant 4. If it's the sine of something positive, like this one is, we would draw it in quadrant 1, because sine values are positive in 1. But if it was arc sine of something negative, we would draw it down here in quadrant 4, because sine values are negative. So again, I know it has to be quadrant 1 or 4, because that's the range of inverse sine, which you haven't memorized yet, but you'll need to. Sine values are positive in 1, negative in 4. So if it's arc sine of something positive, we sketch the triangle in 1. If it's arc sine of something negative, we put it in quadrant 4. All right, the rest of the question is going to seem very familiar because we know sine as opposite over hypotenuse. So this angle near the origin, label his opposite side as 2x and his hypotenuse is 1. (99% of the time you're going to need the third side. So leg squared plus leg squared is hypotenuse squared. So Pythagorean theorem. And if this side is in terms of x, This side, it makes sense that this side's in terms of x too.
Wait, where did you get 9?
9?
That's A.
Oh,
That's A.
my bad.
A squared plus b squared equals c squared. I'm just going over. I know you guys have practiced Pythagorean theorem a lot, so. So I did SOHCAHTOA to set up the triangle, Pythagorean theorem to find the third side of the triangle, and then finally SOHCAHTOA to finish. What y'all need to understand though is because I can't give a numerical answer for this, either because it's in terms of x or it's a spot that I don't memorize, the best that you can do is draw a picture of it. This angle is the angle that has a sine of 2x. His opposite to his hypotenuse is 2x. So to finish this question, now we can use this cosine value. I want to know what's the cosine of that angle. Cosine is adjacent over hypotenuse. And of course anything over 1 is just itself. So the answer to that is square root of 1 minus 4x squared. So we'll need to focus on how to draw the triangle, what quadrant to draw the triangle in. Most of the time it's quadrant 1, but you can miss it if you just always assume that. But then we'll need SOHCAHTOA to set up our triangle, Pythagorean theorem for the third side of the triangle, and then SOHCAHTOA to get our answer. And that will be consistent for all of those questions. And again, that part is probably about 40% of what you will need to be able to do once we get to the quiz. Okay, let's jump over to worksheet